Okay, great. Okay. Okay.
We can see your screen.
Okay, great. Hi, everyone. I'm Shiting Kane from Huawei. Today, I'm going to share about what we did in the Kong release in the IBM use case. And in this use case, I was responsible for the DCAE and the policy realization. Basically, we just realized the runtime configuration for DCAE through policy. So in today's agenda, I will go through the background of the cloud lease line, the IBM use case, and then the realization for the runtime configuration, and the third about the demo. So first about the background. This background, so basically, we realized the cloud lease line in the Jakarta release. So for operators, we provide the cloud lease line services, and for enterprise users, they may buy a cloud lease line service from the operator. So let's say if I am a enterprise user, I can make an order like I want a CLL service from company A to cloud B, and I want 1 gigabyte. So that's the background scenario. But in this use case, but in many scenario for many users, they will face with one issue. Like the 1 gigabyte for me is enough for most of the time. But like for some period, like the 5 p.m. to 8 p.m. or 9 p.m. in this period of time, there would be a large throughput coming to my cloud lease line. Like I am an enterprise user, maybe I have many tenants on my cloud lease line, and at that period of time, the throughput is very high and exceeds 1 gigabyte. So for those users, they do not need to upgrade their service to 2 gigabyte. They can only buy a extra bandwidth assurance service. What does it mean? Like we can detect the real-time bandwidth usage. If you buy the service, the extra bandwidth assurance service, and if we detect the real-time bandwidth usage exceeds like 80% of the bandwidth that you buy, let's say 1 gigabyte, and we will help you to increase your the maximum bandwidth, the network resource that we allocated to your CLL a little bit. Let's say 30%. Okay, so it's gonna be 1.3 gigabyte. And once if we detect the bandwidth usage is back to normal, and we will just adjust back the network resource. So that's the use case. That's a scenario. And in this use case, we wanted to realize the bandwidth assurance. So let's say for users, they first buy the CLL service, and then they have the right to cancel or add a bandwidth assurance service. So what we have to do is to translate the user human language intent to machine intent in the UUI component. And then we have to distribute this machine intent to DCAE, because the flag used to control the closed loop to control the bandwidth assurance is set in the DCAE component. So what we have to handle with is we have to make out the runtime configuration. The closed loop assurance flag can be transmitted to here. So what we did is to utilize the policy component. This is a very high-level architecture for our IBM use case. In this use case, it can explain about the CLL creation service, and also can explain the bandwidth assurance service. So just give you a quick idea about what it works. So first, let's say I want to buy a cloud lease line service from company A to cloud B of 1 GB. Okay, now it's a human language, right? And this whole human language intent will be translated to the machine intent in our IBM system. And we will analyze it and find that it's a create CRL intent. We will just go this flow. We will call SO and so as to call SDNC to create the CRL service. But one day I feel like I do not want the so suppose that I buy the CRL service with the bandwidth assurance service. Okay. So if someday in the future I feel like my normal bandwidth is always below 1 GB, I wanted to remove the service. Okay, that's fine. This intent coming here and we detect it's a modify intent, right? Modify the configuration for one specific CRL, and we will analyze it and to form the configuration in a policy format. The format we have defined it in a template that we will talk about it later. So we just send the configuration in the policy in the format that we defined, and then it's running in the policy PDP engine. And the DCAE will have a thread keep talking to the policy component, and it will keep retrieving the latest data from the policy. And once it's get updated, it will change the flag to change the closed loop assurance status to off. So at this time, for the bandwidth that we detected, let's say the bandwidth is 0.8 GB, and the real-time bandwidth increases to 1 GB, and then increases to 1.2 GB. And okay, these bandwidths are all detected and pushed to SDNC and then pushed to DCAE. So DCAE know about the real-time bandwidth is exceeds 1 GB, right? It's 1.2 right now. But I will not do any operation because like the status is off. But if the status is on, when I detect the real-time bandwidth usage is more than 1 GB, I will increase the maximum bandwidth I allocated for this CRL. So at this time, if the closed loop assurance status is on, I will make another operation. I will increase the maximum bandwidth and send this request in the policy format. So this time it's another policy. I will send to policy, and policy will transmit this request to SO, and then to SDNC, and then to modify the maximum resources I allocate for this specific CRL. So this is a closed loop. So in this use case, like we utilize the policy to transmit our runtime configuration. So how did we realize it? So this graph explains it. Like in this case, we utilize the policy Zacamo PDP, and we also add a policy sync sidecar. This is what we did. Basically, the UI will analyze the intent, and then it will, if it's a bandwidth assurance intent, it will send the intent in the policy format, in the policy template, and send the template to PDP engine and make it and push it and make it run. So once it's running in the Zacamo PDP engine, the policy sync will actually the policy sync will keep sending a thread to the PDP all the time in order to get notified once there is something updated in the Zacamo PDP engine. And then once it retrieves back the latest configuration, it will store it to the volume. So the slice microservice container will also have a thread to keep talking to the volume and retrieving data, and then so as to make changes of the runtime configuration. And next slide, next two slides, I will explain about the step 2, 3, 4, 5 in detail. So for the step 2, I said there are several steps in sending the policy. That is up to the policy. It's up to the up to the policy mechanism. If we wanted to use a new policy, first we have to define the policy type. So here we define that we have a CLL ID first, and then the closed loop status to control whether the CLL is under assurance, and then the original bandwidth. So this is the policy template corresponding to the policy type. So the second step in sending policy, we have to create our policy. So in this part, this is the request body. We have to define the CLL ID. So here is just an example. In reality, it should be a very long number. And then we have to define the user intent, because like it's on or off, and also the original bandwidth for the CLL. And once we create the policy, it didn't finalize. We still have to push it to the PDP engine. If you do not push it, it will not run in the PDP engine. So our policy sync cannot retrieve it. Because in policy mechanism, we can create a lot of policy, but which policy is in usage, it depends on which policy is running in the PDP engine. So we have to do this third step. And next, for the policy sync, this explain how we retrieve the data from the policy PDP engine. This stands for the step 3. So we have a HTTP request to that PDP engine to retrieve the data, and reformat the data into a new format and write it to the volume. And here is a mechanism that can detect whether there is a policy already in the volume. Let's say if for CLL1, there already has a policy set in the volume, I will just refresh it. If not, I will write a new one here. And then there is a thread in my slice microservice container. The thread will keep talking to the volume and retrieving data as well. And once it detects that there is a policy file set it in the volume, it will retrieve it and analyze it so as to change the configs. So in this case, in this use case, that our policy sync sidecar can be reused in our DCAE. So for other microservice components, you can also utilize this one. And the way to deploy the policy sync is to add these in the Helm chart of your microservice. And you can modify the duration, and also you can modify the policy ID as well. So if you wanted to save the resources, you can just, usually we will put it for 120 seconds. And for the policy ID, of course, you can change, but what you have to, you have to pay attention to us. If you change the policy ID here, you must make sure that the policy is sent here. So remember, this is the template for the policy, the middle one. So you just have to make sure the policy ID match the policy ID that you defined in your Helm chart, so it can match the policy. So it can match which policy is the policy to use to transmit the runtime configuration. And then we can see the demo. This is the UUI. We use the UUI to create our CLL and create our CLL assurance service. I just modified the video a little bit. because what we care about is how DCAE react. And the full video, I will upload it later. And so for now, we can see that so now we can see that our CLL is created. It's the first intent, and also I add a assurance service. So what these two stand for? It stands for like I want a CLL service from company A to cloud B with 1 GB, and also I want a cloud I want a bandwidth assurance service. Okay, let's create it. And then in our postman, we can send a request to policy to retrieve the latest data. And we can see that in the policy, it shows that the CLL has been created successfully, and the CLL ID is 900 blah blah blah. And the original bandwidth is 1 GB, and the closed loop status is on. And okay, I'm sorry. And in our use case, we use a simulator to simulate the real-time bandwidth. So we write a script, and now we're going to run it. So it will keep pushing data to simulate different real-time bandwidth data. And then we open the monitor. And here there are two lines. The green line stands for the 1 GB, the network resource they buy and we allocate to them. It's 1 GB. And the blue line shows about how the real-time bandwidth usage is changing. So now it's very, very low. And suddenly it's changing up to 1 GB. Because he buy the bandwidth assurance service. So supposedly our maximum bandwidth allocated to them will increase correspondingly. And now you see it's going up. Speed up a little bit. So you see that once it's coming down back to normal, the temporary bandwidth assurance service is working. It will turn back to normal, the original value he ordered. And then let's modify the assurance intent. Let's just remove it and to see what will happen. We will just remove the assurance intent. And now we will check the policies first to verify it's working. Yeah, you see here, after checking, the closed loop status has been turned off. And you see at this time, the real-time bandwidth usage is going up again. And supposedly the green line will not change because the service has been turned off. No matter the real-time bandwidth usage is going up or down. Okay, now it's going down. And the maximum bandwidth will not react. So this is our demo for the runtime configuration in DCAE. And that's all for my presentation for today. And thank you. Any questions?
Just a comment, very good presentation. Very useful to understand the mechanisms behind and how those different components interact to each other. So very valuable input. Thank you.
Oh, thank you. Thank you for your comments.
Shooting.
Yeah.
Since you already defined the policy development point using the policy server, and then in a different part of the network, the policies are being enforced and validated by DCAE, how much of an effort you think it will be to take a look at zero trust fundamentals and try to deploy zero trust using ONAP, using this particular proposal?
Actually, using it is not that difficult because like we have made the policy sync sidecar deployed and we added to the DCAE components. So basically, first you have to change the Helm chart because we have changed the Helm chart already. You just to make it run. And secondly, we also upload the policy template already to our wiki. So if you wanted to try this demo, you can reuse the template. But what I think is more valuable is like we just do a example about how we can utilize policy to transmit a runtime configuration. So next time, if in other POC or other demo, they wanted to transmit runtime configuration, they can create their own policy type and policy. That's not difficult actually. You just need to design your policy template, and then you just make the data correspondingly. This template is defined in Tosca, I think. So probably you do not need to change too much. You just change the properties that you wanted to transmit. So yeah.
Thank you.
Yeah, you're welcome. Like at first, when I trying to do this, when I trying to learn about the policy, I feel like it's so tough because like there is some policy type and some policy, and you still have to push it into the policy PDP. And there also are 3 different policy engines. But like but like after you know about it, it's not that like complex. You can because the template has been defined. You can just reuse the template. Yeah.
Thanks. Good explanation.
Okay. Welcome. Okay. That's my presentation for today. And thank you very much. Yeah. Okay. I will stop sharing.